This series of videos is a review of topics related to class design, inheritance, and polymorphism. So please be careful to note that this is not meant to be an entire instructional set of videos about these topics. These videos assume you already have a baseline level of knowledge about writing your own classes, about inheritance, and about polymorphism. And in these videos, it's just going to be a review of some of the important ideas related to these concepts. So again, this should not be your first time hearing these things. This is really just meant to be an overview and a review of some of the more important topics about class design, inheritance, and polymorphism. So let's begin with talking about class design, specifically about writing your own classes. So we know that in Java, everything comes down to classes and objects, right? Classes and objects are the main idea of most object-oriented languages, including Java. What a class does is it defines really a blueprint of what an object will look like. So you can think about a class as kind of like a blueprint or a recipe or kind of a template of these are the important things that we need to know about all objects of this type, and these are the behaviors or actions that those objects can take. So it's a blueprint of what an object is going to look like. Once you have that class written, you then can use that class to create instances of your class, which are your objects. So your class is the blueprint, if you think about it that way, and your object would be the 5 houses you make from that blueprint. Or your class is the recipe, and your object would be the 12 cookies you make based on that recipe. Now, classes contain instance data and methods. So our instance data describe the characteristics, or sometimes it's called the state of our objects. So these are basically the things that describe an object. If you were to think about this object in your mind, how would you describe it? What are the characteristics of that object? All of those things are listed as instance data variables in our class. And then our class also defines the functionality or the behaviors of our object. So these are all the things that our objects can do or that actions can be taken upon our object. So again, when you're sitting down to write a class, you want to sketch out what are all the things that I can use to describe objects of this type. Those are going to be your instance data variables. And then also, what are all the actions that I want these objects to be able to take? What's my functionality? What are the behaviors? And those are going to be your methods. So all of our classes are going to be made up of these instance data variables and methods. There are a couple of basic building blocks that all of our classes that we write are going to contain. And then once you include these basic building blocks, then you add on to the class with more specific things that are specific to that class. So you think about this as like your baseline. This is your starting point. All of your classes are going to contain these core elements, and then you build on the class with other things that are specific to that class. These elements that I'm going to talk about are very important, but they're often not the most fun to write. All right, so usually when we're writing our own classes, we want to get into kind of really the reason we're writing that class is for some methods or behavior or functionality specific to those kind of objects, and that's usually what we want to think about. But you have to have these basic building blocks in first in order to get the class up and running. So our basic building blocks are our instance data variables. So these again are the characteristics of our object. One or more constructors. This is how we set up our objects. A collection of getters and setters. These are the public methods that allow us to access and modify the characteristics that describe our object. And then 2 methods that we override from the capital O object class, a toString method, which creates a text representation of our object, and an equals method, which allows us to compare 2 objects. So these elements are our core building blocks that we're going to put into every class we write. And we're going to start with these elements, these core building blocks for all of our classes. Again, these methods and features of our class aren't necessarily the most fun to write. They can be a bit repetitive to write these, but they're the core starting place for all of our classes. So that's where we start. Then once we have these elements added and tested and we think, we're pretty confident that they're up and running correctly, then we go ahead and add any of our class specific methods, which again is usually the part we care about with the class is what is this actual functionality? This is the reason why I'm writing this class, but we have to get those other core building blocks up there first. So let's go through each one of these. First off with our instance data. So again, our instance data variables, they represent the characteristics of the object. So this is how we would describe an object. The most important thing to know about instance data variables is that every object we create, so every instance of our class, has its own copy, its own version of each instance data variable. So if you think about a class as a student, and you might think about an instance data variable being a name, a status of whether their tuition is paid, perhaps an address, all of a student ID, all of these different instance data variables that would be characteristics describing a student. If we create 10 students, they're each going to have their own version of all of those instance data variables, right? Each student will have their own name, their own ID, their own address, and so on. So every object has its own version, its own copy of instance data variables. Now, in terms of the code, we make our instance data variables private, and that's to support encapsulation, which we'll talk about shortly. So for this review, we're going to actually go through an example, and we're going to start off looking at that example with instance data, and we're going to be writing a class to represent an employee. So I'd actually like you in a moment to pause the video and start by sketching out all of the different characteristics that you think might be used to describe an employee. So we're going to start writing this class just by creating the instance data variables. So go ahead, pause the video, and just in your mind or on some scratch paper, just think about all the different characteristics of an employee that you might want to represent with your instance data variables. Okay, so hopefully you actually pause that and you have a nice little list there. Now take a look at your list and notice if you just wrote down what the characteristics might be, or if you also thought about what the type of that characteristic might be. Because the first step in designing a class is this idea of thinking about the characteristics. But in thinking about the characteristics, we have to think not only about what is the characteristic, so what is it that it's describing my object, but also how am I going to represent it? So in that way, we're thinking about the type. Okay, so pause the video again, take a look at your list, and jot down next to each one of your characteristics what type might well represent that kind of data. Might it be a string or an int, or might I have to write my own class to represent this? So think about that for a minute. Okay, so hopefully in doing so, you've got kind of a nice little list about different characteristics and the different types that could be used or might be the best to represent those characteristics. Now we're going to actually write a class that's very, very simple. We're going to keep it simple because we're going to use this class, we're going to build on it moving forward, and we're going to use it to represent a lot of other things. So I want to keep the employee class pretty simple. So we're just going to do a couple of characteristics, but you might have listed things like name, age, address, ID, phone number, salary, start date, hire date, percentage work, department that they're in, title, role, a list of people that work for them, so people who they supervise, the name of their supervisor, and many more, right? You can think about a lot of different things that would describe an employee. Again, we're going to keep our class that we're going to write right now pretty simple, but this is in a realistic setting, this would be one of the most important parts about writing your class is what you do first before you ever start coding, which is sitting down and thinking about the characteristics of that object. Now, in thinking about all those, then the next step was thinking about the type, right? So maybe some of you had an employee ID and some of you described that ID by a string, thinking, well, the employee ID might be something like A425, so it needs to be a string. Someone else might say, well, the employee ID actually can be an integer because all of our employee IDs are just numbers, so maybe I can use an int. Or maybe an int's not going to be long enough, maybe I need to use a long, right? So there's different data types you might use to represent different kinds of information. And sometimes it's not going to be clear. I mean, sometimes it is. If you're going to have a salary, you're probably going to use a double, although you could also use a float. But you're probably not going to use an int or definitely not a string. So some characteristics will have very clear data types that should be used. But others, it might be a little bit more subjective over what one you think is the best data type. And two people might sit down with the same instance data variables and decide to use two different types to represent them. So it doesn't mean that one is right and one is wrong, just means there's different ways of going about it. The most important thing is that you put some thought and consideration into the type that you use and that you're able to justify whatever that decision is. So if someone comes to you and says, hey, why did you choose to represent ID as a string instead of as an int? You can say, well, this is my rationale. So that's the most important thing, is to think through your decisions and be able to justify why you made certain choices. Okay, so let's go ahead and start with our employee class. So I have, I'm going to be writing an Eclipse. I'm going to create a new class. I'm going to call it employee. I'm going to follow my Java naming conventions for classes, which are upper camel case. So starts with an uppercase letter. Typically for classes, they're singular nouns. That won't always be the case, but it's often the case. So this is, I'm going to call my class employee. And I'm going to start with just my instance data variable. So again, I'm going to keep things very simple. I'm just going to describe my employee objects by an integer ID and by a name. Now, again, in a realistic, larger setting, you'd be describing an employee by many more characteristics than just these two. You also, again, might choose to describe an ID by a long or by a string, or something like that. But I'm just going to keep things a little bit simple for now and use an integer. For name, you probably would have not just a name, but maybe a first name, a last name, a title, a middle name, a suffix, all different parts of aspects of someone's name. You might even choose to create a class called name, so that instead of just using a string, you would actually write a class called name, and that class would be described by different strings, first name, last name, title, suffix, things like that. So that would actually probably be the most robust way to go ahead and design these classes if you were going to really use this employee class as part of a larger system. But again, I want to just keep things kind of simple. So I'm just going to make name a single string and ID an integer. Now, instance data variables are going to be private. This again is meant to support encapsulation, the idea that each class is in charge of its own data and that we don't let outside classes directly access that data. So we keep it private. And also you'll note that instance data variables are declared. Remember, a declaration happens where you state the type and the name of your variable. So this is the declaration statement for ID. This is the declaration statement for name. So declaration means when you state the type and the name of the variable. Now for instance data variables, this declaration happens inside the class. So here we are inside our class brackets, but outside of any method. So of course we don't even have any methods yet, so all of these variables are declared outside of any method, but that's how instance data variables are. They're always going to be inside the class, but outside of any method. So that's our very first step. That's our first building block for any class we write, is thinking through what the instance data variables should be, what the type should be to represent them, and then also writing those as variables, keeping them private. Now, when we're writing a class, the other thing we want to be doing is kind of switching back and forth between writing our class and testing it out. So at the very beginning, as soon as I create my employee class, I'm also going to create an employee tester class. Oops. And this class is going to have a main method. I'm going to be able to run code from this class. And what the purpose of this class is, I'm most likely creating this employee class to do something with it, to use it in some way. This tester program is not that. This is not ultimately how I want to use my class. This is really just a test program to make sure that the code I'm writing to describe an employee is correct, it's working properly. It's going to let me test the different methods and test everything out to make sure it's working. This is essentially a class or a file that I will use while I'm designing my class, and then I won't use it again. Once I know that my class is up and running and accurate and I'm confident that it's working properly, I can pretty much throw this tester program away. So it's really just meant for the process of while I'm writing my class. So I can't do much with my employee object yet, but what I can do is I can just declare an employee object like that, and I can compile this tester code, and that's all that happens so far. Okay, that's pretty much what I can do at this point, but I should be able to do that, and that's what I will do at this point. Okay. All right, so again, instance data variables are the first building block or component that I'm going to add into my classes. The next is constructor, one or more constructors. So the job of the constructor is to set up the object. Its purpose is to create an object, to take in our initial information about that object, and to use that initial information to set up our instance data variables. Okay. Now we take that information into the constructor either as a parameter, or if we don't want to take in a parameter, we can sometimes use a default value, which we would declare as a constant. Okay. Often our constructors are overloaded, which means we have more than one. A lot of times we want to give the users of our class more than one way to set up an object. So if we give them one constructor, that allows them only one way to set up an object. But if we give them more than one constructor, it allows them multiple ways to set up the object. And a lot of times that's good. We want to give them choices. This is often the case when we have a lot of default values. We want to say, well, hey, you can set up an object by telling me all the initial information, or maybe you want to give me some initial values, but you want to use those defaults for other initial values. In those cases, we can give you different constructors to do that. So it's kind of a flexible way to design your classes to allow a user of your class different ways to set up the object. Now, the constructor is what is called when we use the new keyword. The new keyword is how we invoke the constructor, and we'll take a look at that in a minute. We'll come back to the slide in a minute. So let's first write our constructor. Now, important things to note about the constructor is that they have a visibility. Typically, we'll be working with public constructors, but eventually we'll also take a look at why you might want to make a constructor private. But constructors do have a visibility. The other important thing about them is they have no return type. So it's not the case that they have a void return type. They have no return type at all, meaning you put the visibility followed directly by the constructor name, and the name of the constructor is the same as the name of the class. So this is my employee class. My constructor is called employee. Same capitalization, same name. And then you follow with the parameters. So typically we're going to start with a constructor that will take in all the information we need to create an employee object or an object of our class. So I'm going to take in and the ID and the name. So this is the information I need to set up an employee object. I say, hey, if someone wants to create an employee, you have to tell me what that employee's ID is, and you have to tell me what that employee's name is. Okay. Then I'm going to take that information and I'm going to use it to initialize my instance data variables. So I'm going to say my ID gets that value you sent in as a parameter, and my name gets that value you sent in as a name. Now, the instance data variables are associated with an object, right? If we create 10 employee objects, each one of them is going to have an ID and a name. And those instance data variables are accessible throughout the entire class, so I can use them in any method in my class. And they also last as long as the object lasts, so they persist with the object. Parameters, on the other hand, only last as long as the method is running. So when this particular method, which is our constructor, when this method is over, these parameters are lost. We don't get to keep that information. So any information we want to keep about an object, it has to be put into instance data variables. So that's why we do this with a constructor. We say, hey, give me some information, but I want to store it. I want to save it and keep it with that object. And so to do that, I have to put it in an instance data variable. That's the only way to be able to store or save information about an object. Okay, so a lot of times this looks funny to people. It's like, well, why are you just passing in the data and then saving the same data? But it's actually two different things. It's coming in as a parameter, which will be lost once this constructor ends, and we're saving it as instance data variable, which will persist as long as the object is around. Okay, so let's go ahead and test our constructor. So now we can go over to our tester program and we can actually create a new employee, and we'll create employee 123. We'll call this employee Wally Worker. Okay, so I can't do much else with my object yet, but I can invoke the constructor, and I should be able to do that, and this code should compile. Okay, so there we go. My constructor works. Now, oftentimes with a constructor, what you'll see is people don't like to come up with these different parameter names. They're thinking, why do I have to call it new ID and new name? I'm just sending in the ID, I'm sending in the name. So the most common structure that you'll see is that the parameter names are the same as the variables. But of course, now how do we distinguish between the two? Well, you distinguish with the this keyword. So when you put this dot in front of a variable, that refers to the instance data variable. And when you don't put the this dot, that will refer to the parameter. So this dot ID is the instance data variable for ID, and just ID with no this dot is just the parameter. This dot name is the instance data variable for the name, and without the this dot, it's just the parameter. Eclipse is helpful in that it also uses the coloring of the variables and parameters to help you remember that. So you can see here the instance data variables are blue and the parameters are brown. Other IDEs do similar things like that as well. Okay, so this is the most standard way that you will see a constructor written, is with the parameters having the same name as the instance data variables and then differentiating between them using the this dot. In general, you want to use different names for things, but for constructors and also for setter methods, the parameter and the instance data variable, it's really representing the same thing, right? It's the ID of the employee. It's just the parameter is the one coming in from whoever is calling the constructor to create the object, and the instance data variable is the one being saved with that object. But the data is really the same. It represents the same thing, and that's why it's okay to use that same name, because it's representing the same thing. It's just that one is the instance data variable that'll be saved, and the other is the parameter. So this would be our kind of basic form of our constructor. But what if we said now, well, we actually have a default employee ID. Maybe before employees are assigned an ID, they get a default. Maybe that default is 0 or something like that. And sometimes we use that ID for employees who maybe, again, maybe they haven't finished the hiring process or they haven't been assigned an ID yet, or for whatever reason, we want to have a default value that we can use for an employee's ID. Well, if I'm going to have a default value, I would declare that as a constant. I can decide whether I want to make that constant public or private. Remember that it's okay for constants to be public because a constant, by definition, the value can't be changed. So we wouldn't have an outside class coming in and changing our constant because it's a constant. It can't be changed. So it is okay to make it public. In deciding whether you want it to be public or private, you just have to think about whether or not you want outside classes to have access to that data or not. If you want that value visible to other classes, then make it public. If not, then make it private. So I can choose either one. I'd again have to just kind of think through, be able to justify my decision. If I said that I really only wanted that value to be visible inside the class, I would just make it private. I will make it final because it's a constant. And then typically my constants I do make static. We're not going to quite talk about that in this video, but that is convention to make your constant static. It just saves a little bit of memory space. I'm going to follow my naming conventions for constants, which is all caps with underscores to separate the multiple words. And I'm going to call this my default ID and give it my value of 0. So here's my default ID. Now, of course, someone creating an employee, another class or another class that's creating an employee object could use, if I had made this public, they could just use this default ID. So for example, I could say employee, and let me change this to employee 01, and this is employee 02. And I could use the employee.default ID. What's another? Tanya, the temp. Okay. So I could use that. But if there's a default value, I might want to give a more streamlined way for someone else to use my class. And how I can do that is I can provide another constructor. So I can provide a second constructor and say, okay, if you want to use the default ID, then you don't need to tell me the default ID. I'll just use it. You just tell me the name. Pass me in the name. I'll use that name. And then for the ID, I'll assign the default ID. So this is typically how we'll set up our constructors. Usually you'll have one that takes in all the information, and then you might have additional constructors that take in less information and use default values for the information that isn't taken in. One thing that's really important is that you always want to initialize every single instance data variable in all your constructors. So you never want to have a constructor where you don't initialize one of your instance data variables. You want to make sure all your variables are initialized in every constructor. The difference is just whether it's being initialized using a parameter value or a default value. Okay. So in doing this, now I can go back here and I can say, well, yeah, this actually saves some space or some work for someone using my class. I can just go ahead, of course I have to save it. I can just go ahead and say, yeah, here's the employee's name, and then you just go ahead and use the default ID. Okay. Now, one thing you'll notice in this setup is that I sort of have some repeated code here, right? It looks like I'm kind of duplicating code. Even though in this case it's just one line, it exists in both these constructors. Anytime you find yourself duplicating code, shudder, especially if you're copying and pasting code, which we never want to do. But even if you find yourself typing code and you think, hey, I kind of already typed this code somewhere else, you want to stop and think if there's a better way to structure it, and there almost always is. A lot of times we can take that code and we can put it in a method and then invoke the method multiple times. In the case of a overloaded constructor, so these are overloaded constructors. Remember that an overloaded method is a method with the same name but different parameters. So this is the employee constructor, which takes an int and a string. This is the employee constructor that just takes a string. So these are overloaded constructors. What we can do is we can actually invoke one constructor from the other, and we do that with the second use of the this keyword. So this is what this would look like. It's saying, hey, call this other constructor, the one that takes in an int and a string, and pass these two values as parameters, pass the default ID and the name. So this line here actually invokes this constructor, passing in the default ID and the name that came in as a parameter, which will then use those two parameters to update the instance data variables. Okay, so this is what this looks like. A lot of people kind of like to think about it like this. It's as if you're calling the employee constructor, sending in those values, And this is actually really what is happening behind the scenes, but that's not the syntax that Java gives us. So this is okay to think about it this way, that, hey, what I really want to do is I want to call this constructor like this, but that's just not the syntax you use. So that is kind of what's happening. And again, it's okay to think about it like that, but this is the syntax. It's this we use the this keyword followed by passing in the parameters. Okay. Now you might think, well, yeah, it's that one line that's repeated that I saved. Like, is it really necessary to do this? But it really is best practice. And the reason is eventually this constructor might get a lot more complicated, right? There might be a lot more code here that we use to set up an employee object, and we wouldn't want to duplicate that code across both constructors. Or if we had, 5 instance data variables, all with different default values, we might have 5, 6, 7 different constructor options we'd give a user of our class. And we don't want to duplicate that same code across all of our constructors. So it really is best practice to write kind of one fully implemented constructor that does all of your setup code. And then for your additional overloaded constructors, just invoke that initial constructor, passing whatever parameters and default values that you want to pass along. Now, to invoke our constructor, we do use the new keyword. So you saw that when I came over here to my tester program, I created 2 new employee objects with that new keyword. The new keyword actually does 3 things. The first thing it does is it allocates the necessary memory for the object. So when the Java virtual machine hits that new keyword, it takes a look at the class. In our case, says, hey, looks at the employee class, says, hey, how much memory do I need for an employee object? Let me go ahead and allocate that memory. The next thing it does is it executes the constructor. So it actually jumps back to our constructor and executes line by line. So for this line here, when we hit the new keyword, first that memory is allocated. Then we jump back here and we start executing this constructor line by line. First line is a call to another constructor. So we jump up here, execute this line by line. Then this constructor would end. We'd return to here. This constructor is over and we'd return back to here. The final thing that new keyword does is it returns that address or reference to the place in memory where that object was created, and it stores it in that variable. So what that might look like, again, the first step is we allocate some space, right? So here we've got an employee object. We know we need, excuse my rudimentary drawings here, but we know we need an integer ID. We need space for that. And we know we need a space for a string name. So that's step 1. Step 2 is we actually go ahead and execute the constructor, which we know in our case, let's say this is our employee 2 that we've created. We're creating the value of 0 there. And for the string name is actually also an object. So this would actually point to somewhere else. And we're creating Tanya temp. Sorry, it's actually kind of tricky. This is really messy. So that's the second step, is we actually go through the code in our constructor, which will initialize all of these instance data variables. And then the third step is we had that employee O2 variable on the left-hand side of our equal sign right here. So the third step is this memory location, wherever this is in memory, this address is returned and linked up to emp02, employee O2. So what's actually stored in employee O2 is a memory location to somewhere else in memory where our whole big object lives. And those are the 3 things that the new the new keyword does. It allocates the space, executes the constructor, which should set up all those variables, and then returns that memory address to the variable. So that's what is stored there. Now, one last note about constructors. There is something in Java called a default constructor. I hate this name. It's not a good, very descriptive name. Some people do call it a no argument constructor, and that actually is a better name. A default constructor is just a constructor for which there are no parameters. It basically just looks like this. So it's a constructor because it's just public, same name as the class, no return type, but it doesn't take any parameters. This is a default constructor. Okay, that's just a term that's used in Java. Again, I don't like the term. I don't think it's very descriptive. No argument constructor is a lot more descriptive. It's a better term, but you will hear that one of the technical terms is a default constructor. Now, there are some kind of strange rules about a default constructor. If you don't have any constructors in your class, so let's say this is what my class looks like. Behind the scenes, Java will add a default constructor. And that default constructor would look just like this. It wouldn't actually do anything. It wouldn't assign any values to instance data variables. It wouldn't do anything. It just would be there behind the scenes. You don't actually see it. It's not in your code, but it will be in the bytecode. It will be part of your class. However, once you write a constructor, any constructor, Java no longer does that. It no longer adds anything in behind the scenes. Okay, so because now I've got these two constructors, this class does not have a default constructor. Okay, so as soon as you add your own constructor, that's it. Java doesn't give you anything else. But if for some reason you didn't add a constructor at all, behind the scenes, Java would put in that default constructor. You can also write your own default constructor. So if I write a constructor like this, then yes, now my class does have a default constructor. Default constructors will become important when we talk a little bit later about inheritance, because there are some rules about parent and child classes related to default constructors. So for now, just make sure you understand how default constructors work, when your class will have it and when it won't have it. And again, the basic rule for that is if I write one, it's got one. If I don't write any, it's also got one, because in this case, Java put it in behind the scenes. But as soon as I do write a default any other constructor, Java doesn't give me anything extra. So in this case, my class would not have a default constructor. My general rule of thumb, which this is not Java convention, this is just my Jessica Masters convention, is if you don't have a meaningful default value for every single instance data variable, do not use a default constructor. So in this case, for employee, I don't have a meaningful default for name. There's no default value I can use for name. So I'm not going to provide a default constructor because I wouldn't have a default value to give to the name variable. And I don't want to leave that variable uninitialized. So in this case, I would not provide a default constructor. Now, again, that is not a Java convention. That is my personal convention. You will find lots of people who always put a default constructor into every class. And that there's nothing wrong with that. It's just a different approach. Okay, so you can read up a little bit if you want on kind of the pros and cons of including a default constructor. I've given you the standard that I follow, and you can sort of develop your own as you go along.